All right, happy Wednesday. Again, it's a virtual day. If you didn't watch video number one, that's fine. Video number one dealt with the uh, going through number 5 on page 2 of this packet. Now we're on to page 3 of the packet, using the half-angle identities to evaluate expressions. And we want to talk about these because these are a little more complicated, but we're still following one of the formulas. Okay? So these are on your identities, pink sheet. The half angle for sine here is number 24. The half angle for cosine is number 25. And for tangent, and its 3 options, is number 26 on your pink sheet, lower right-hand column. Okay? So there they are. They're written down for you on there. You can copy those down at any point in time. Now, using them, we wanted to evaluate, if we want to evaluate these things, and the kicker here is this exact answers only. There's a little more work involved with simplifying these because they're going to look a little funky. And you'll see why once we start into them. Okay? So, sine of 15 degrees. Well, the sine of 15 degrees would be the sine of 30 degrees divided by 2. Okay? Now, on the unit circle, the reason, so if I scroll back up here now, I'm looking at this formula right in here because I'm dealing with sine. So I have to look at where this angle lies to determine if I go with the positive or the negative. So 15 degrees is in quadrant number 1, and sine is, oops, that's a bad sign. In sine is positive in quadrant number 1. So I'm going to go with the plus. If I happen to be at somewhere in the sine of, let's say, 210 degrees, and I used 420, then that sign would be negative because now I would be in quadrant number 3. Okay? So based off of that fact, I'm going to be using the positive. So this, that's blue, so this is positive square root of 1 minus the cosine of 30 degrees, and inside that is still 2. Okay, so far, not looking too bad. I can handle that so far. Oops, grabbed the wrong one. Need to grab this one and bring it down. There we go. So now what we're looking at is, well, the cosine of 30 degrees is square root 3 over 2. And that's still over 2. Still inside. All still good. Now, okay, keep change flip tells me that I'm going to have here let me go up to the side here. If I go 1, I'm changing it up. I'm not going off to the side. I'm going to go right below it. So now that I've fixed that, I'm going to go, so this is all inside the square root. And now what I've got inside the square root is I've got 1 minus the square root of 3 over 2. That's my top up here. and that's going to be divided by 2, which means that's going to be multiplied, that whole thing is going to be multiplied by 1/2. Which means that becomes the square root of 1/2 minus the square root of 3 over 4. That internal fraction now becomes 1/2 is like 2/4. So then that would become the square root of 2 minus the square root of 3 all over 4. And all of that is still inside of that fraction. Well, because we're inside that fraction, or that, excuse me, not inside that fraction, that's all still inside that radical. And what we learned way back in algebra was, if we had the square root of a fraction, that was the square root of the top divided by the square root of the bottom. So this is going to become, actually let me tap the brakes on that one. This is going to become the square root of 2 minus the square root of 3 all over the square root of 4, which the square root of 4 now is 2. So this is the square root of 2 minus the square root of 3, and then outside the fraction is just 2. And that, ladies and gentlemen, is the sine of 15 degrees. You will, when it comes to these, have square roots inside square roots. Okay? Let's try a cosine 1. Okay? So the cosine of pi over 8 would be like the cosine of pi over 4 divided by 2. Which now I'm utilizing number 25. So again, I need to look at, okay, pi over 8 is in quadrant number 1. Everything's positive in quadrant number 1. So this is going to be positive big radical of 1 plus the cosine of pi over 4, and all of that being divided by 2. So then we scroll down here a little bit. So now I've got the square root of 1 plus the square root of 2 over 2, and all of that being divided by 2. If I make 1 be 2 over 2 right off the start, I could simplify this radical, or the top, the numerator inside the radical, as 2 plus the square root of 2 over 2, then again, still over 2. All that's inside. Keep change flip. Now then, that becomes big radical 2 plus the square root of 2. Let me go back and let me colorify it so that it's the same as the left example here. 2 plus the square root of 2 all over 2 there. And then that now is being multiplied by the reciprocal of the denominator, which is just 1/2. So then this becomes 2 plus the square root of 2 over 4. All of that inside of a radical, which simplifies itself down to the square root of 2 plus the square root of 2 all over 2. Lots of 2's in that problem. Lots and lots and lots of 2's in that problem. Okay? Just to give you a sneak peek here. So let's do a tangent here. Let's do the tangent of 7 pi over 12. Well, that is going to be the tangent of 7 pi over 6, then divided by 2. If you see the pattern, you just divide the denominator by 2 to find what the half of it would be. So then now you got your choice. Well, we could do the radical, 1 plus the cosine, or excuse me, 1 minus the cosine over 1 plus the cosine, but then I'm dealing with a radical. Not necessarily too keen on that one. We could do 1 minus cosine over sine. We could do sine over 1 plus cosine. I'm going to choose the middle one. 1 minus sine. So then this is going to be 1 minus the sine at 7 pi over 6. Correction, cosine. I read my own problem wrong. 1 minus cosine of 7 pi over 6, all divided by the sine at 7 pi over 6. Sometimes that one's easier. Sometimes the first one is easier. The radical one will all get you to the same spot. It just takes more work to get there. Okay? So this becomes 1 is 1. Cosine at 7 pi over 6 would be negative square root of 3 over 2. Sine at 7 pi over 6 would be negative 1/2. So we're sitting here now. My numerator, again, 1 is like 2 over 2. So my numerator is actually 2 minus a negative is plus the square root of 3 all over 2. And then that is still all over 1/2. Keep, change, flip. I'll write it out for you. Gets me that. The 2's cancel each other out. 2 cancels out 2 there. Still left with the negative 1. So then this is negative 2 minus the square root of 2. You would get that using any one of those 3 formulas, identities. Okay. So that concludes video number 2 for Wednesday. Tomorrow is so Thursday, I should say. I shouldn't use today and tomorrow. Thursday is a work day to work on finishing the purple worksheet and getting questions answered. We will have the hour-long classes on Thursday. We will have Google Meets open. The Google Meet code I will put in here too is West Pre-Calc. Okay? And so you will, if you have questions or if you need to get a hold of us on Thursday, it's supposed to be an F. We'll start over again. Okay? We'll see you on Friday.